This is topic 6 of Windows Server Administration, and this topic is file services. And within this topic, there are 3 other subtopics: offline files, file systems, and FSRM, or File Server Resource Manager. So first of all, offline files. Offline files is a feature of Windows Server, and offline files can be enabled in a shared folder, so that users can connect and download files to their local machine. Now, this may be useful for people who only come into the office some days. So for example, if you had some not absolutely critical data, but some documents or some shared data, and you had some salespeople that were in the office, let's say on Monday and Friday, for example, you might want to enable offline files for them. Stop my video just to make this a wee bit better. So yeah, so you might want to enable offline files. Now, if lots of users were to arrive all at once and they had this offline files feature turned on, and they all tried to sync at the same time, this could consume large amounts of network resources. So to fix this, you can enable the option optimize for performance. Okay, optimize for performance. And what that'll do is that'll enable offline file caching in the background. Okay, and this is a feature that's built in. Now, the default setting for offline files is only the files specified will be made available offline. Okay, so not every single file is not made available offline by offline files. You have to specify which files you want. Okay, so some options in offline files. Caching for offline files can be configured on the server, and with additional options such as optimize for performance that I talked about in the previous slide, and only the files needed for caching should be available offline. So there's no point in making lots and lots of files available offline. Sync options on client computers. So sync options can enable optimization on the network and can prevent large groups of users connecting to the same time to sync the offline files. And then the always available offline option at the client side will allow a network resource to always be cached. Okay, so you should use that quite carefully, the always available offline. Now, obviously we have cloud services like Azure and G Suite now that we can use for office services. However, in the past, those weren't always available. And also, especially in Scotland, this can be an issue. Let's say you had a company and some of the staff worked from laptops and they weren't in the office all the time. And let's say on specific days, they were in areas of the Highlands where they have no internet. So, you know, they might not be able to connect to Azure and they might not be able to download and sync the latest data. So becoming less and less of an issue, but still a possibility that they could be someplace without internet. Okay, so some space-saving technologies built into Windows Server. NTFS, the new technology file system, has its own data compression. That's a built-in feature, okay? Other space-saving technologies include compression tools like WinZip. So WinZip copies files and then compresses them. The only issue is to view the files, you have to unzip the files again to view them. Finally, there's a server feature called data deduplication, and that can identify repeated patterns, and it actually works at the binary level. So I've got a little diagram of how the dedup works. And what happens is you have a file or set of files, and if you were to convert this file to look at a binary representation of it, little chunks of that binary would likely follow the same patterns. So for example, inside a file with thousands of binary digits, it's likely that if you were to break it up into groups of 8, 1, 0, 1, 1, 1, 0, 1, some of these groups would be the same. So these get treated as chunks. And If the chunks are the same, only a single copy of each one's kept. Then they're run through a compression algorithm, placed into a chunk store, and a reparse point is created. And the reparse point will just allow you to reverse all of this and get the file back out. And this is a modern method of space saving. And in Azure and virtual machine volumes, this can actually save a lot of data. So this is something quite new to Windows Server, and it will let you do it in cloud volumes. And there's a video I can link you to that will explain and demonstrate the value behind this. So looking at file systems now, plus RAID and the distributed file system. So firstly, what actually is a file system? So a file system controls how data is stored and retrieved. And without a file system, data placed on a storage medium would just be one large body of data with no way to tell where one piece of data stops and the next piece of data begins. So if you imagine, and the analogy and the structure is actually taken from real paper-based file systems. So an actual filing cabinet. If you imagine, if you had files of data on all sorts of things, and you opened up your filing cabinet and you just threw them in without a file system or a filing system, then when someone came to you and said, can you get me this file? It would be quite difficult to find it because you'd have to rake through all the different files. So a file system allows us to separate data into pieces, give each piece a name, and then we can isolate it, identify it, and retrieve it when it's called. So file systems or filing systems have structure and logic rules that allow us to do that. So here's some examples. One of the most common is the file allocation table. And one that we probably use is FAT32, although that's becoming less and less common and being replaced by exFAT. So the problem with FAT32, the limitation is 4 gig. And when you save a virtual machine, a VMware virtual machine, you might notice that when you go to save a disk, all right, it offers you the chance to either save the disk, all right, as one file, which I often suggest to do, which just makes it easier to delete, or you can save it as multiple files. And if you save it as multiple files, those files will be less than 4 gig. And the reason for that is so you can copy it onto a FAT32 USB stick and move it around. Okay, so that's a little VMware trick to overcome the limitation of a FAT32 USB stick. Right, NTFS, it's not very new anymore, but the name of NTFS is actually the New Technology File System. This was introduced in 1993 with Windows NT and is the most common file system for end users. And as we know, to do Windows deployment services, we need an NTFS formatted volume. Now, a newer file system in Windows is REFS, the Resilient File System. And this is more likely to be used in Azure cloud setups. And this is Microsoft's latest file system, and it's designed for very large volumes of data. So that's something that you can look into in your own time if you're interested in Microsoft's Resilient file system. Then just looking at some other operating systems, HFS Plus used to be the Apple file system, and it was used for iPods, Mac computers, and the Apple X server. So this was replaced by a newer Apple file system called the easy to remember APFS. And that's been the file system in Apple since the Mac OS High Sierra operating system. So those are two Apple file systems. In Linux, generally we use the ext4 file system. Okay, it used to be ext3. Before that was ext2, and this is most commonly used in Debian-based operating systems. Then we have this file system called ZFS. Now, ZFS is designed for giant volumes of data, and it has clever duplication and recovery facilities to it. And you would get ZFS if you were perhaps running an ISP, or if you had your own, sort of global infrastructure and you had to store a lot of data. You would have a lot of servers, and you would have the disks on the servers configured to run the ZFS file system. So a couple of the global financial organizations I've worked in have had large global ZFS setups. And the ZFS file system actually comes from the BSD operating system, but it can be used in Linux as well. And it has lots of clever features in it designed for massive amounts of data. So another feature of Windows Server is the distributed file system. Now, DFS, not to be confused with ZFS. ZFS is much better, I think. DFS would be, I use DFS in the summer. So here's an example of when you would use DFS. You have two sites, Site A and Site B. Okay, Site A has a server, and the server has some shared storage volume that all the staff can access. Then you want all of the staff at Site B to be able to access that same storage volume and to be able to save stuff to it so that the staff can cooperate. Now, generally, this was more popular before the rise of cloud technologies. So you could create a DFS volume, a distributed file system volume. And what Windows Server would be able to do is it would be able to sync the data across both disks, which would be transparent to the end users. And when they looked at it, they would think that it was the same disk. All right, they wouldn't know that they were syncing. Now, there's a couple of like configuration options that you can do with DFS, and by enabling those, you can, for example, let it sync overnight. So what I normally do, we bring up a server from London, and the staff will be arriving from London in 2 or 3 days. So I'll usually set up the server and start the DFS replication so that when they arrive, they can access the shared directory exactly as if they were in the office in London. And what they don't know is that it's actually a local disk that they're accessing. It's just been synced. And I usually leave it to sync overnight so that it has time to copy all the data. Okay, so some disadvantages of NTFS that might not be obvious straight away. Some mobile devices like Android and tablets don't support NTFS. Okay. I remember quite a while ago, Linux didn't used to support NTFS. You used to have to add some drivers so Linux can view NTFS. At the moment, and I'm not sure if it's still the case, but certainly 3 or 4 years ago, Linux didn't support exFAT. So you had to add some drivers to get exFAT to work. Just a case of installing a couple of packages, though it wasn't a huge deal. Now, apparently, NTFS formatted drives can be read by Mac computers, but you need extra software to write to NTFS disks. So I don't know if that's, you have to install a whole utility or if it's just a case of running an update. Finally, some older media devices such as DVD players and TVs and digital cameras don't support NTFS. So if you were running your company and you were, for some odd reason, you decided you were going to store all the data on DVDs, all right? And to check that data, you were going to use a DVD player. You were going to pop the DVD in and just browse and see that the data was there on an old TV with a remote control. That's possible. However, just be aware that some old DVD players, TVs, and digital cameras don't support NTFS. So you could end up in trouble there with your strange filing system. NTFS doesn't have a system for guaranteeing performance, like newer file systems, like ZFS, for example. And NTFS has got a limit, 16,000 folders in a single directory. Okay, so this isn't a problem for a lot of people, but if you worked in a company that was very folder heavy, you might run into some problems there. I've never personally tested this, so I can't say what happens, but I'm sure we could write a bash shell script, an ash script, or a Python script to generate directories and see what happens if we try to create more than 1600 folders. We could create a whiptail menu called the whiptail folder generating utility, and then you could type in the number of folders you want and then press go, and a little whiptail progress bar could go along the bottom. But I think that's beyond the scope of this course. So a bit about RAID. RAID is a redundant array of inexpensive disks. And for this course, we just need to remember what each of the RAIDs is. Now, you don't need to know about RAID 2, RAID 4, RAID 6. You only need to know RAID 0, RAID 1, RAID 5, and RAID 10. Okay? Now, the easy way to remember this is just remember RAID 0. If you remember that RAID 0 is striping, you'll be fine. Now, with RAID 0, we save a bit on disk 0 and a bit on disk 1. A bit on disk 0, bit on disk 1. So this data, A, is split between the two disks. If this disk breaks, we're going to lose half the data, but it does have a performance advantage. Okay, RAID 1 is mirroring, which means in RAID 1 we have a mirror of the data across the two disks. If this disk fails, we've got the data here. Okay. Finally, RAID 5 has this thing called a parity bit that allows us, if one of the disks fails, to use the parity bits to recover the data when we put a new disk in. Okay. RAID 10, the last one, is just a combination of RAID 1 and RAID 0. And RAID 10, you can say that RAID 10 is striping and mirroring. Okay, so it gives you the best of both worlds. You need 4 disks for RAID 10 though. I think you can do RAID 5 with 3 disks. However, in this graphic, it has 4. So the easy way to remember all of these 4 is just remember that RAID 0 is striping. If you know RAID 0 is striping, you know RAID 1 is the other thing, the mirroring, okay? Then RAID 5 has this parity bit. If a disk fails, we can recover it. And finally, RAID 10 is just these two added together. Now, RAID disks are configured with numbers, okay? And those numbers are called LUNs, logical unit numbers, all right? In February this year, I received a job. I got a contract to go and perform a RAID migration in the data center in Edinburgh for a company. So I had to do a course on the best way to perform RAID disk migrations. And what I was doing was actually just a chassis swap. It was a failed chassis, a failed power supply. Both power supplies were flagging up as faulty. And so I had to go out to this RAID array, and it had 48 2 terabyte drives, and they were all linked in some clever array, and we had to take each of them out very carefully and balance them on this table. And the real key was putting them back in the right order. So definitely not something that you want to do if you're not being organized. It just requires organization and being careful. But the whole idea is this disk can fail. Then we just walk up to the RAID array, pull the disk out, okay, because SATA is hot swappable, and then we just plug another disk in, okay? And these disks are clever enough to use this parity bit to rewrite the data on here. Okay, so finally on this file class, some useful tools. So something we're going to use in the lab today, FSutils. FSutils is a tool built into Windows that lets us do various different command line operations that let us display and manage file and drive properties. So with FSutils, you can create X number of files with X size. Okay, and in the lab, it shows us how to do this. It allows you to perform tasks related to the file systems as well. And if you fire FSutils in without parameters, it will display a list of potential subcommands in classic Windows style. So some more utilities. Difficult one to say. ICACLS, okay, is a utility that allows you to modify access control lists inside NTFS directories from the command line. netshare is the command. So if you've ever in Windows right-clicked on a file and gone to properties and chosen share, ticked share this folder, you could do that from the command line, and the command you would use from the command line would be netshare. All right, so netshare is the Windows CMD utility for sharing files across a network. netshare. And ICACLS lets you change permissions from the command line. Okay, so the last part today is a role in Windows Server, and that is File Server Resource Manager, FSRM for short. So File Server Resource Manager is a role that we can add to Windows Server, and it will allow us to manage file resources. So it's actually got 5 uses, okay, or 5 use cases here. So what can we do with File Server Resource Manager? We can perform quota management. So we can limit how much data is allowed to be stored in a particular directory. We can do file screening. We can do classification management. So we can apply criticality to particular files on a storage volume. We can do file management tasks. So base file management on file classifications. And we can finally generate reports about how full volumes are. So here's some examples. File Server Resource Manager, we could create a 200 meg quota for every single user in the network's home directory, and then send a notification when they are using 180 megabytes of that 280 200 limit. Okay, so we can generate an email that would get sent to them, and it would say, warning, you're using almost all of your storage space. Finally, we could schedule a report that runs every Sunday night at midnight. It generates a list of the most recently accessed files from the previous 2 days, and this can help you to determine weekend storage activity. And I've put a link to the Microsoft docs on FSRM there, when you can have a look at all the different details. So a bit of terminology. Quota types. A hard quota will stop writing to the disk when you're at 100%. So if we've got a 200 meg limit on a folder, once it reaches that limit, you will not be allowed to save anything else in there. That's a hard quota. Soft quota will allow you to keep writing to the disk, but will generate some kind of an alert either to the event viewer or via email to where you would like it to go. Okay, so that soft quota will still allow you to save to the disk, but an alert will be generated. Hard quota will stop writing to the disk. An active screen performs an action, and a passive screen, much like a soft quota, will just generate a report. So those are some of the terminologies. And much like the administrative templates in group policy that we looked at in Lab 5, we have quota templates in File Server Resource Manager that are ready to adapt and design for specific purposes. Let's have a look at the lab for today. So Lab 6, to go with topic 6, is about File Server Resource Manager and capacity management. And in this lab, we're going to create an additional member server. So we're going to need to use the server 2019 ISO. Now, up till now, we've only had one server running at the moment, but we're going to create a new server and add it to the machine, to the domain, and we're going to use this command, the netdom join command. So I'm going to give you a demonstration of that just now. So what I'm going to do is create a new virtual machine, okay, and I'm going to just set the compatibility back just in case there are any issues, and choose I will install the operating system later. Okay, now you might notice Windows Server 2019 is not there. Windows Server 2016 will work just fine. Okay, and I'm going to call this server, okay, so member one. Okay, so member servers are additional servers inside a domain. All right, I'm going to save it in here. We'll create a new folder for it called member one. Oh, did I spell that member one? Let's spell it member one. Member one. Okay, and we want to save member one in member one. So that's saved on my backup drive there. Choose BIOS for the firmware type. This is up to you. This depends on what kind of machine you have. I'm just going to leave it on 2 gig of RAM, and we'll leave it on that just now. We can change this later. Okay, and just accepting defaults for everything else. Now we'll create a new disk, and as I said earlier, let's store it as a single file, which will just make it easier for me to delete later on, as this is just a lab that I'm setting up. Okay, member one is a fine name for the disk, and let's customize hardware. Let's take away the sound card and printer because we're not going to need these on a command line server. Finish. Now, in VMware, I'm going to edit the settings, and I'm going to attach an ISO image here. And the ISO image that I'm going to attach is the Windows Server 2019 ISO. Okay, so let's attach Windows Server 2019, and then let's start member one. So hopefully we should see the loading Windows screen coming up. And while this is loading in the background, just going to go back and look at File Server Resource Manager. So in Server Manager, by this stage, we should have DHCP, DNS, Windows Deployment Services, Active Directory domain services all running on the server. To add File Server Resource Manager, we just choose Add Roles and Features. Select the server we want to add it to. Inside File and Storage Services, inside File and ICSI Services, we tick File Server Resource Manager. Okay, and then just complete the wizard. I've already installed it on this server. Once that's done, we can then access File Server Resource Manager from the Tools menu. So opening up File Server Resource Manager, you'll see it looks like all the other Windows roles that we've looked at in here. And if we were to open Quota Management, we could right-click here, and there's some quota templates there. So already, if we wanted to set a 10 gig limit, we could create quota from this template. We could also perform file screening on particular file types. We can create storage reports. We can do classification. So this is all built in. And because we've done group policy, DHCP, DNS, we should start be getting used to using this Microsoft Management Console here, where we click on things on the left and things happen in the middle, and we have additional options over here at the right. So let's go back to member one now and see how it's getting on. Okay, so I'm going to choose the UK keyboard layout, just so that I have the @ symbol in the right place, and the double quotes symbol. Apart from that, I don't feel that there's that much difference. So the difference between this setup and the other setup is we're going to install this server without the desktop experience. So just skip the product key because we're not, we're just doing this for a lab. So up till now, we've been using the desktop experience, but we want member 1 to be a file server that's command line only. So we're going to choose server standard. Okay. And hopefully this should take us to the installation screen. So let's do a custom installation, and you can see there's my virtual disk there. And that's the installation kicked off there. So because we're not installing the graphical environment this time, you'll find that this is actually a little bit quicker than you would expect. So going to the lab, part 1 explains that we need to set up a server without the desktop experience. And that's doing what I've just showed you there. Okay, this just explains, try and balance out the amount of RAM that you give the machine. It's becoming less of an issue nowadays, but 2 or 3 years ago, some people were still running with 4 or 8 gig of RAM. Right, so once we have the member server running, we're going to, through the command line, join the member server to the domain. Okay, and then shut down and reboot. Then what we're going to do is we're going to run these 2 netsh commands, and these 2 commands will set firewall rules on the member server. Then we're going to make a directory called media, and we're going to run this icacls command on media. This grant everyone, don't worry about this syntax here, this just grants permissions. Once we've granted permissions and set permissions in the access control list, we then run the net share command. So just a bit of background on this. Bear in mind, okay, and I'm going to try and look for a file, and of course I probably won't be able to find a file because I just installed this server, but I'm going to open Windows Explorer here and explain roughly what I mean. So if I right click on downloads and I go to properties, okay, this is a familiar properties window that opens, but if we go to the security tab here, or we go to permissions for system down at the bottom, this allow and deny here, this is an access control list. Okay, it's not an access control list like we're used to with Cisco, okay, but it's an access control list. Okay, no IP access class in or out here, and we can, anything that's allow or deny is an access control list. Now, I believe this is a discretionary access control list. Let's have a look back at member 1, see how it's getting on. Okay, so we have member 1 at 94% ready. So I'm going to pause the recording now and I'll return when this is fully installed. So here we are on member 1. We're logged in, and the first thing we see is we need to set the administrator's password. So this is keyboard input only. So let's put the password in now. You can't go back in the password, so you need to type it in order. Now, I would strongly advise using my Edinburgh College password, but it's up to you. Okay, so $Edinburgh College, capital E for the last character, and $1 again, and then press return to enter. Okay, I've set the password now. And we're in. We are into the member server. So this is all you see in a server without the desktop experience. So if I do the ipconfig command here, we'll see that we're getting some kind of 172.16, some kind of NAT IP address from VMware. So what we're going to do is go to the settings of this virtual machine and take it off of NAT, and we're going to add it to a LAN segment. Now, I've had some problems with LAN segment 1, so I had to create a new LAN segment. That's why I'm using LAN segment 2 now. So let's save And then let's try the IP config again. Okay, that looks good. We have no IP address now. All right, brilliant. 10.10.10.10. And look, we're getting the IP address from ec.com, okay, from our domain controller. So now if we do ping ec.com, okay, we're getting a reply from the domain controller. So DNS is working, ICMP is working, layer 3 is working, DHCP is working as well. And if we do IP config /all, we can see that the DHCP is enabled and the DHCP server is being identified as 10.10.10.1, which is our domain controller. And the connection specific DNS suffix is ec.com. So we have a member server and a server, okay, connected. And we can validate this if we just go into DHCP, and then in the DHCP manager, we open out IPv4 and go into address leases. We'll see there's our member server there. There's the actual host name of it. So the next stage is to add this member server to the domain, okay? And to do that, we're going to use this command here, netdom join. Okay, now the red parts of the command need to be changed to suit your particular environment. Okay, so let me copy this and see if VMware will allow us to paste. Good, great. So to do that, I went to edit and actually chose paste in from VMware, not from inside the machine. Okay, and VMware was clever enough to send it into the machine. Right, now the password's good and the username's good, but we need to change the domain name. Okay, so what I'm going to do is change that to ec.com. Now, at the moment, this is going to fail because I haven't put the computer name in, but I want to kind of save this command on my sort of command line clipboard. So I'm just going to press enter and I'm going to do Control-C to cancel. And that means when I press up, that's there. Because what we need to know now is we need to know the computer name of this machine in order to join it to the domain. And we can get that from the DHCP, or we can use a command which is echo percentage computer name percentage. So let's go to the member server and let's try echo percentage computer name. Okay, here it is here. So what we want to do is put that into this computer name variable there. So I'll just type it in by hand since we've got it there on the screen. So let's do, okay, win -5, and I'm going to guess that's an O. Okay, it might be a 0. We can come back and change later. ICAQHRC85. Okay, first time, let's go. Oh, now that looks good. The computer needs to be restarted to complete the operation. Right, the command for restart is shutdown /r. Okay, so let's restart the member server. We're about to be signed out. Okay, and let that reboot. So in the lab, these red bits are specific to your domain and your username and your password. This will not work by itself. Okay. Once you've added the server, you then need to paste these two commands in. Watch out for VMware turning these into @symbols. Reboot again. Then we're going to make a drive. Okay. So we're going to make a share on our member server using this net share command. Okay. And then what we should be able to do from server 1, okay, when we do Windows key and R, we should be able to navigate 10.10.10.10, I think the IP address was, /name of share. This should let us navigate to the share, okay? If I just copy that, what we should also be able to do, once the directory has been shared on the member server, is we should be able to map network drive here. So if I right click on network and do map network drive, it's going to ask me what's the path to the network drive, and it's saying //server/share. Okay, what it means by that is give me where the share is and what's the name of the share, and we should be able to navigate to it with that. So once we've done that, okay, the final bit of the lab is just creating some directory and applying some quota on it with File Server Resource Manager. And then there's a little bit to use the FSutils command to create a file that's bigger than we're allowed to store to generate an alert. So the last part should be fairly straightforward. There's nothing too complicated in the last part. And then finally, we just generate a report on a file system that we filled up, and that is Lab 6.